Hello, this is Physics Masterclass. Today we will be talking about distance and displacement. To start off, let's differentiate distance and displacement. So, distance is the magnitude of length traveled. You will only get a numerical value when you do distance. It is only a numerical value. You get the numerical value and you get your units. For displacement, however, it is the measure of position in comparison to starting point. Now, before we get into examples, we need to discuss direction. We will be using standard direction, so it would be north, east, south, west. Alright, now that we established the differences, the magnitude, and this being the comparison of position, and we discussed the direction, we can start with the example. Let's say a guy, some person, a gubero, they walk 5 kilometers west. Then they walk 3 kilometers south. They then walk 2 kilometers east, 1 kilometer south, and finally 3 kilometers east. So, with this distance, all we want to do is just add up the numerical values. So, what we should do is start with our 5 kilometers and then add it to the 3 kilometers and add it to the 2 kilometers and add it to the 1 kilometer and then add it to the 3 kilometers. We added this all up. We have 5 plus 3, that's 8, plus 2 is 10, plus 1 is 11, and plus 3 is 14. The distance traveled was 14 kilometers. Now, for displacement, it's a little different. So, going back to our direction chart, some directions counteract each other. North and south, west and east. So, we have both west and east. What we should do is we should divide this up into its, vertical and horizontal direction. You have alright, in standard physics, north and east will always be considered positive, whilst west and south would always be considered negative. Think of it like the x and y axis. So we have negative 5 kilometers, which represents our west, 5 kilometers west, plus our positive 2 kilometers, which is our 2 kilometers east over here, plus our 3 kilometers east, which is over here. So for our x component, our displacement would be 0 kilometers, but we're not done yet. we still have this 3 kilometers south and this 1 kilometer south. So you have negative 3 kilometers minus 1 kilometer equals to negative 4 kilometers. This would in turn mean that you displaced 0 kilometers horizontally, but you displaced 4 kilometers south. So your distance would be 14 kilometers. Your displacement would be 4 kilometers south. Notice that distance is larger than displacement. In physics, your distance should always be above or equal to your displacement. However, your displacement should always have a direction. There's also one other thing that we should go over, and that is constructing vector lines. So at the beginning of the year, we were taught about vector lines. Hold on. We were taught about, let's say we go 5 kilometers east, and then we go 2 kilometers west. Our resultant vector line would be our displacement. So we have to do our rule tip to tip and draw it like this. Actually, let me label it in red. And this would be 3 kilometers east. This would be your displacement. This is how it will be drawn. This concludes today's physics 0.5 masterclass. Relatively simple concept. Just try to envision these movements in a 2D space. Alright, that's all.